Welcome to OpenGeology. We are here discussing about the CIL previous year solutions. This is part 8 and we will see from questions 71 to 80. These questions are from the exam on 2017. But before we begin, you can join our CIL Geologist test series. There are 100 plus tests are there, belongs to all sections like the general awareness, English, reasoning, aptitude, geology, as well as the 11 full length test. You can join for other exams as well like NET, GATE, GSI. So let's begin with our first question. According to the elastic rebound theory, an earthquake is produced when? So what elastic rebound theory states? It states that whenever you bend a material like the earth crust, it will behave like the elasticity. But after reaching a break-even point, it will break into two parts and sudden release of energy will happen in terms of faulting. So the maximum energy will be released when the rocks abruptly slips past each other. Okay, abruptly means during the faulting period. What else you can read about this? The different types of fault. Okay, and terminology related to all faults. Another question is, which of the following features is not associated with the orogeny? So orogeny is the, what is orogeny? Orogeny is the mountain building process. Okay, mountain building process where two plates are coming towards each other and both of them when collide, mountain type of structure will form. This is called the orogeny. Okay, mountain building process. So whenever both of them come towards each other, there will be faulting. Reverse fault forms during the destructive plate boundary. And then you have the folding, because you are putting pressure from both sides, so things will bend, folding. Then intrusion of plutons, the subducting plate will be partially melted and plutons will be emplaced. But it is not associated with the passive continental margin. So there must be active continental margins like the boundaries of plate. So third option will not associated with the orogeny. What else you can learn from this topic? You can learn the three types of plate boundary: constructive plate boundary, destructive plate boundary, and conservative plate boundary, and all the features associated with them. Then another question is, measurements of geophysical quantities in boreholes differs from those in the surface surveys. Okay, so what are those quantities and how they differs? So all of these are different. Like, let's say the operating environment. So like instruments, which are the logging instruments, when we go the downward fit borehole dimensions, they must be capable of operating submerged in the drilling muds of fluid. So the borehole will have the drilling mud and fluids, so the instrument must be able to measure in that situation. There must be a measuring direction. So whenever downhole logging, the instrument measures the sideways, like this is a borehole, so instrument will measure the sideways. Okay, so into the geological formation. That means the evaluation properties like porosity and fluid contents, the instrument should able to measure in the directional way. Then drilling alterations. Sometimes the drilling introduces changes like the mud cake accumulation, there can be fluid invasion. So borehole measurements are specifically designed to account for these type of disturbances. So they will not get the actual thing. There is drilling mud also. Okay, there can be fluid invasion, like somewhere if you encounter to some fluid, so fluid will flow in the borehole. So you have to think all about this. So here the correct option will be our option number B. Another question is, which one of the following is not true? So the value of G varies over the surface of Earth, but it is not with the longitude. How? Let's see. Now understand the ellipsoidal modeling of Earth. So in the ellipsoidal modeling, the reference value of G is axially symmetric and depends on the latitude and altitude, not the longitude. So we describe the value of G along with the latitude, like how much it is away from the equator, okay, in both northern and the southern hemisphere. So makes it completely independent of the longitude. This is a factual question, you should remember of this. So what other things you can learn? Other things you can say about the changes of gravity value with the help of like Boger anomaly, free air anomaly, and all of and like the going away from the earth surface, going down the earth surface. You can have the terrain correction, the tidal corrections. So all of the basic concept you can remember by allowing these questions. Now another question is, gemstones are commonly found in pegmatites. Now what rocks are the pegmatites? These are exceptionally coarse grained rocks, the pegmatites. So you can divide the igneous rocks into the three parts. Like first one is your extrusive rocks, okay. Extrusive means whatever rocks they are solidified after magma reaching the earth surface, so above the earth surface. Then second is the intermediate or the shallow depth, okay. So let's say this is the earth surface and magma is coming. So if it is placed in the shallow depth, so it will give you the fine grained, not this is the finest, okay, and this is the coarse, but compared to that it is coarse. Then there is the deep seated, okay, deep you can say deep batholith, okay. So let's say magma is placed in deep in the earth, let's say 7 kilometers, 10 kilometers. So what it will give enough time to cool slowly, and slow cooling will lead to maximum or the increase in the grain size. So it will be coarse grained rock. Pegmatite is the example of this deep igneous bodies. Now another question is, what is a channel which contains island whose width is more than 3 times the width of water? So let's say this is your river body, okay, and there is a bar, you can say mid channel bar, or you can say island, okay. So this is the water that is flowing. So if its width is the 3 times the water channel, then we calls it an unbranching type of river. Now you can say that what is anastomosing river? So it is a kind of unbranching river. So unbranching river can be further divided based on the island width and the water width. So the primary difference is that anastomosing is a specific low energy subcategory of the unbranching river. While anastomosing rivers are unbranching, not all unbranching rivers are anastomosing. Let's say you have another river which there is island, something like this. So the width of water is almost equal to the width of your island. So this will not come into the category of anastomos. So it is not a kind of reference that we are trying to make. So only if it is 3 times the width of water, we call that unbranching river. Another question is, a rock was magnetized when it was at 20 degrees south of equator, but today it is drifted to 20 degrees north. Now what will be the angle by which its inclination differ from that of its present true? So here is the formula, tan I equal to 2 tan lambda, where I is the inclination and lambda is equal to the your latitude, okay. So it was 20 degrees south. So calculate the original inclination when it was on 20 degrees south, it is 36 degree. Present inclination on 20 degree north, again it is 36 degree. Then the absolute difference will be of 72 degree, because in the southern direction the difference will be on the dip angle, okay. One side it is dipping this side and another is dipping on this side, while on the equator it is the horizontal. So correct option will be B, that is 72 degree. Another is what is a Wilson cycle? So Wilson cycle is describes about the closing and opening of the oceans. You can say it is also associated with the continental evolution. Let's say how it is, although the correct answer is B, but let's see it in detail. Okay, so this is example of Wilson cycle. There are 6 stages, 1, 2, 3, 4, 5, 6. First is the rifting stage where the continent starts breaking. The modern day example is your East African Rift Valley. Then we have the juvenile stage where divergence is happening like the Red Sea. Then you have matured stage where divergence has happened to a limit that it is a great ocean, you can say. So the example is your Atlantic Ocean. Then you have the declining stage where the boundary or you can say the margin of that ocean start collapsing, and you have the convergent boundaries along with them. The modern example again is the Pacific Ocean. Then you have the terminal stage where ocean is about to end, example is Mediterranean, and the suturing stage where the ocean has completely wiped out and now you have the mountain like the Himalayan mountains. So this is a very good cycle to remember, and from exam point of view you should remember all of the examples in there. Okay, now the angle of repose for most loose sand is. So let's say a sand is going to compile. So what is the angle after that the sand will start to flow freely? So it is 35 degrees Celsius. By definition, it is the steepest angle at which sloping surface of loose material remains stable without sliding. Okay, so the correct option will be second. Now the last question is, the term Vadose zone is usually applied to the. So it is related to the vertical distribution of groundwater. In the from the ground surface there is a line above which there is water as well as the air is present. We call that a zone of aeration or the Vadose zone. So in the uppermost part we have the soil water zone. In between we call the intermediate Vadose zone, and the lowermost part we call as the capillary zone. Then there is water table, which is denoted by the reverse triangle, you can say. Okay, water table. Below which there is completely pores are completely filled with water, and we call it as phreatic water or the zone of saturation. So Vadose zone is this. It is applied to a region where above the water table. It's all about for today. We'll see you in the next video. Again, you can join our CIL Geologist test series. There are 100+ tests belonging to each section. Thank you.